Today we are going to start matter. So we know that matter is composed of tiny particles known as the molecules. These molecules are held together by a force of attraction. This force of attraction is called the interparticle force of attraction or the intermolecular force of attraction. They also have intermolecular space in between them. The intermolecular force of attraction and the intermolecular space is different in different matter. So it varies from matter to matter. You can find in chalk the intermolecular force of attraction will be different from the intermolecular force of attraction in water. But for any substance, the stronger the intermolecular force of attraction, the smaller is the intermolecular space. The stronger the intermolecular force of attraction, the smaller is the intermolecular space. And weaker the intermolecular force of attraction, stronger is the intermolecular space. So in any matter, if the intermolecular force of attraction is strong, then the intermolecular space will be less. And if the intermolecular force of attraction is weak, then the intermolecular space will be larger. Now, this matter exists in three states. Those are namely the solid state, the liquid state, and the gaseous state. Whatever matter you can find. Before this, I want to tell you what is matter. Matter is anything which occupies some space and which has some mass. And that one we have already learnt in the previous class 6 and 7. Now, this matter exists around us in three physical states, and those are solid, liquid, and gas. For example, water exists in all three states of matter. Water in the liquid state, you can find commonly it occurs in the liquid state. Then ice in the solid state. Water and ice are chemically the same. So ice is water in the solid state, and also you can find water vapor or steam that exists in the gaseous state. So one thing you must remember, chemically water, ice and water vapor are same and contain the same type of molecule, only they differ in their physical states. The question is, what causes the difference in the state of matter? Why water exists in all the three states? Not only water, the different substances, most of the substances, they exist in different state of matter. So the question is, what causes the difference in state of matter? And the difference you can find in the three states of matter, it is because of the following two properties. The first one is the intermolecular force of attraction, and the second one is the intermolecular space between the molecule. So these two make the difference, and because of difference in these two property, we can find there are three states of matter. The intermolecular force of attraction is the strongest in the solid state, weaker in the liquid state, and it is the weakest in the gaseous state. So this is what the intermolecular force of attraction. You can find in the solid state the intermolecular force is the strongest. In liquid state you can find a weaker intermolecular force of attraction, and in the gaseous state you will find the weakest intermolecular force of attraction. On the other hand, you can see the intermolecular force of attraction, intermolecular space is the smallest in the solid state, larger in liquid state, and the largest in the gaseous state. So the space between the gas particle is very large. Liquid you can find a smaller space, and it is the smallest in case of solid state. Now you can see from this picture it is very clear to you that gases have very large intermolecular force of attraction. You can see here these gas particles are widely separated from each other. There is a large space in between them, and that is where the intermolecular force of attraction is the weakest. In liquid you can find comparatively less intermolecular space, and that is where the force of attraction, intermolecular force of attraction, will be more. And in case of solid you can see the intermolecular space is very less. They are closely packed with each other, and that is where they are having the strongest force of attraction. Now the interconversion of state of matter. You can see when we heat water, it is converted into steam. Whenever you heat water, this water is converted into steam. So that is a liquid changes into gas. When we cool water, it is converted into ice. So when we keep some water here inside the freeze, that is cooling of water. The water is converted into ice. Similarly, other substances also can change their states without changing their composition. Here you can see this, when we heat water it is converted into steam. When we cool steam, once again it is converted into water. When we cool water it is converted into ice, and ice if you keep outside the refrigerator on heating, it is once again it is converted into water or liquid state. This is called the interconversion of state of matter. So you can find in interconversion of states of matter, solid can change into liquid, liquid can change into gas. On the other hand, the opposite direction also you can see, this gas can be changed into liquid, and liquid can be changed into solid. So this is known as the interchanging of states of matter. From solid to liquid, liquid to gas, and gas to liquid, and liquid to solid is known as the interconversion of state of matter. Now boiling point. The fixed temperature at which a liquid changes to gaseous state is called its boiling point. Now you can see boiling is the process in which a liquid changes into its gaseous state, and it occurs at a fixed temperature. The temperature is a fixed temperature, okay, a definite temperature. So this temperature, fixed temperature at which a liquid changes to gaseous state is called its boiling point. For example, you can see water boils at 100 degrees Celsius. Next is melting point. The fixed temperature at which a solid changes to liquids is called its melting point. Here melting also takes place at a fixed temperature. Freezing point. For example, you can see the ice melts at 0 degrees Celsius. Freezing point, the fixed temperature at which a liquid changes to solid. Suppose if you take the water changes to ice, that also takes place at 0 degrees Celsius. That means the melting point of a solid, particular solid, is equal to the freezing point of the solid, freezing point of the liquid. So freezing point of water is also equal to 0 degree like its melting point. So at this temperature, ice changes to water, as well water freezes to ice. Similarly, here 100 degrees Celsius, what you see, here also you can find water changes to steam at 100 degrees Celsius. Steam also changes to water at 100 degrees Celsius. So freezing point of a liquid is equal to its melting point. Boiling point is numerically equal to its condensation point. Condensation point or condensation, it refers to the process in which a gas changes into the liquid state. Now we will start kinetic theory of matter. So whenever we come across this word kinetic, means it is related to motion. So this theory of matter, it is related to mainly the motion of the particle of the matter. So the main postulates, it has many postulates. So main postulates of kinetic theory of matter are: all matter is made up of very tiny particles called molecules. In the solid state, the particles are rigidly held in position about which they can only vibrate. So in solid state, you can see only a vibrational motion. The particle cannot leave their place, but at the about their mean position, they vibrate. In liquid state, the particles are in continuous motion but are not completely separated from each other. So they can leave their place, but the particles are linked with each other. They are not completely separated from each other. The particles in the gaseous state are in continuous random motion, and they are almost independent of each other. They are almost independent of each other. While moving, the particles collide with each other and with the wall of the container, thus exert a pressure on the wall of the container. The particles possess some kinetic energy due to their motion, because the particles are moving, and that is why they possess some kinetic energy. Now you can see in the solid state, their motion is only vibrational motion, very less motion. So the kinetic energy of the particle in the solid states are very, very less. In liquid state, the motion is more. They are moving from their place also, and that is why the particles in the liquid state are having higher kinetic energy. But the kinetic energy in case of gases will be highest, because these particles are moving in a random motion, and the particles are almost independent of each other. So kinetic energy of the particles depend on the temperature. When we increase the temperature, the motion of the particle also increases, the kinetic energy of the particles increases. So motion of the gas particles. You can see in this picture, this picture shows you about the motion of the particles. The particles are moving in all possible directions, and you can find they are colliding with the wall of the container, and also they are colliding with each other. So this diagram shows you the motion of the gas particle according to kinetic theory of gases. Now kinetic theory explains change of state. You can see when a solid is heated, its kinetic energy increases, because the kinetic energy depends upon the temperature. So the kinetic energy increases and they start moving faster. After some time, these particles become free and the intermolecular space increases and it is converted into liquid. Liquid states are having more intermolecular space. So you can see this is the solid state. Now the particles are closely packed, and when heated, the particles are separated from each other. The space between them increases and they form the liquid state. Then when a liquid is heated, its kinetic energy increases and they start moving faster. So their motion increases. After some time they become completely free and the intermolecular space becomes very large and it is converted into the gaseous state. From this picture you can see this is the liquid state. Now on heating their kinetic energy increases and they start moving very fast and slowly their intermolecular space become more and they are converted into the gaseous state. I hope from this picture the interconversion of state of matter is explained very well using the kinetic theory. Then a law of conservation of mass. Antoine Lavoisier proposed the law of conservation of mass in the 18th century. So according to the law, the statement of the law we can see, matter can neither be created nor destroyed, but can be changed from one form to another, and the total mass of the substance before and after the change remains the same. So this is the law of conservation of mass. In any kind of change, it may be a physical change, it may be a chemical change, matter is not created nor it is destroyed. So that is known as law of conservation of mass. And who gave this law? Antoine Lavoisier. This law is true for both physical and chemical change. Let us discuss some examples of which holds this law of conservation, which obeys this law of conservation of mass. So, example 1. If we keep 1 kg of water in the refrigerator, after some time we will get exactly 1 kg of ice. That means in the change of water into ice, the mass of the matter is neither created nor destroyed. So this shows the law of conservation of mass. Example 2, you see, the mass of an electric bulb does not change when the bulb glows. So you might have experienced this one. So this is both of these are physical change. Another example we will see, during burning of a paper, it seems when we burn a paper, it seems that there is a loss of mass. When we burn a paper, so after some time you will find some very less amount of ash is found. So it seems that there is a loss of mass. But actually, if you see, it is a chemical change. So paper burns in presence of oxygen. And the products are carbon dioxide and water. So this carbon dioxide, water, all these and oxygen, all these are gases. So we cannot see them, we cannot feel them. So if you take the mass of paper and mass of oxygen, if you add them, then you will see that the mass of all the reactant is equal to the mass of all the product, the total mass of all the product. So carbon dioxide and water also you have to consider mass of carbon dioxide produced, mass of water produced, and mass of oxygen consumed in this chemical change. So if you see this one, then you will find that total mass of all reactant is equal to total mass of all product. So now children, your matter chapter is over. Now it is time for you to do the homework. So your homework you can find do all the numbers given in the exercise which is given in your textbook. You can find in page number 5 and page number 6. Learn all the postulates of kinetic theory of matter, and the explanation. Try to go through the explanation of interconversion of state of matter again and again and try to understand it. So thank you. Have a nice day.